First of all, I am grateful to all of you gentlemen that you come to our channel. Today we will talk about black hole. Often the question comes to our mind, what is a black hole? How big are black holes? How do black holes form? What's the size of a black hole? If black holes are black, how do scientists know they are there? Could a black hole destroy Earth? Are there other black holes also in the universe? Today we are going to answer all these types of questions that you can easily understand it. So let's start.
Show the role of black holes in creating and destroying stars and planets. Here's our science correspondent, Palab Ghosh.
A black hole is usually a place in space where no light exists, making it all but impossible to capture on film. Despite this, a team of astrophysicists have managed to photograph a
magnetic fields can tell us about how the black hole eats gas and ejects, possibly a jet or out.
Black holes, the monsters of the cosmos, they move around devouring planets and even stars. Till recently, their presence was only established theoretically. But now, for the first time, we can have a glimpse of an actual black hole in our cosmic neighborhood.
Now, the black hole has fascinated humans for a long time. We have theories on what lies inside it. But that's all that we have, theories, no concrete evidence as to how this giant void functions. But what if you could peep inside a black hole? What would you see? A group of scientists from Stanford University did exactly that. And what they saw vindicated the most decorated physicist of the 20th century.
The fastest growing black hole has been discovered by scientists. Astronomers led by the Australian National University spotted the supermassive black hole about halfway across the universe. It consumes the equivalent of 1 Earth every second. It weighs the equivalent of 3 billion suns.
Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler, after decades of black holes being known only as theoretical objects. The first black hole ever discovered was Cygnus X1, located within the Milky Way in the constellation of Cygnus, the Swan. Astronomers saw the first signs of the black hole in 1964 when a sounding rocket detected celestial sources of X-rays, according to NASA. In 1971, astronomers determined that the X-rays were coming from a bright blue star orbiting a strange dark object. It was suggested that the detected X-rays were a result of stellar material being stripped away from the bright star and gobbled up by the dark object, an all-consuming black hole. Black holes are some of the strangest and most fascinating objects in space. They're extremely dense, with such strong gravitational attraction that not even light can escape their grasp. The Milky Way could contain over 100 million black holes, though detecting these gluttonous beasts is very difficult. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A star. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from Earth, according to a statement from NASA. What is a black hole? A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes. They are invisible. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than other stars. How big are black holes? Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. These black holes are very tiny but have the mass of a large mountain. Mass is the amount of matter, or stuff, in an object. Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy. Earth's galaxy is called the Milky Way. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths. How do black holes form? Scientists think the smallest black holes formed when the universe began. Stellar black holes are made when the center of a very big star falls in upon itself, or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. Scientists think supermassive black holes were made at the same time as the galaxy they are in. If black holes are black, how do scientists know they are there? A black hole cannot be seen because strong gravity pulls all of the light into the middle of the black hole. But scientists can see how the strong gravity affects the stars and gas around the black hole. Scientists can study stars to find out if they are flying around, or orbiting, a black hole. When a black hole and a star are close together, high-energy light is made. This kind of light cannot be seen with human eyes. Scientists use satellites and telescopes in space to see the high-energy light. Could a black hole destroy Earth? Black holes do not go around in space eating stars, moons and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. Even if a black hole the same mass as the Sun were to take the place of the Sun, Earth still would not fall in. The black hole would have the same gravity as the Sun. Earth and the other planets would orbit the black hole as they orbit the Sun now. The Sun will never turn into a black hole. The Sun is not a big enough star to make a black hole. How is NASA studying black holes? NASA is using satellites and telescopes that are traveling in space to learn more about black holes. These spacecraft help scientists answer questions about the universe. The first image of a black hole was captured in 2019 by the Event Horizon Telescope, EHT, collaboration. Over 100 billion stats, our home galaxy must harbor some 100 million black holes. Though detecting black holes is a difficult task, and estimates from NASA suggest there could be as many as 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is dubbed the Unicorn and is situated approximately 1,500 light-years away. The nickname has a double meaning. Not only does the black hole candidate reside in the constellation Monoceros, the Unicorn, its incredibly low mass, about 3 times that of the Sun, makes it nearly one of a kind. In 2021, astronomers revealed a new view of the giant black hole at the center of M87, showing what the colossal structure looks like in polarized light. As polarized light waves have a different orientation and brightness compared to unpolarized light, the new image shows the black hole in even more detail. Polarization is a signature of magnetic fields, and the image makes it clear that the black hole's ring is magnetized. But the question is, what do black holes look like? Black holes have 3 layers, the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in spacetime where the mass of the black hole is concentrated. So far, astronomers have identified 3 types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. Stellar black holes, small but deadly. When a star burns through the last of its fuel, the object may collapse, or fall into itself. For smaller stars, those up to about 3 times the Sun's mass, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small but incredibly dense. One of these objects packs more than 3 times the mass of the Sun into the diameter of a city. This leads to a crazy amount of gravitational force pulling on objects around the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. Supermassive black holes, the birth of giants. Small black holes populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are millions or even billions of times as massive as the Sun but are about the same size and diameter. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't certain how such large black holes spawn. Once these giants have formed, they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. Supermassive black holes may be the result of hundreds or thousands of tiny black holes that merge. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapse of a stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could arise from large clusters of dark matter. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light and cannot be directly observed. Intermediate black holes. Scientists once thought that black holes came in only small and large sizes, but research has revealed the possibility that mid-size, or intermediate, black holes, IMBHs, could exist. Such bodies could form when stars in a cluster collide in a chain reaction. Several of these IMBHs forming in the same region could then eventually fall together in the center of a galaxy and create a supermassive black hole. In 2014, astronomers found what appeared to be an intermediate mass black hole in the arm of a spiral galaxy. And in 2021, astronomers took advantage of an ancient gamma-ray burst to detect one. Astronomers have been looking very hard for these medium-sized black holes, study co-author Tim Roberts, of the University of Durham in the United Kingdom, said in a statement. There have been hints that they exist, but IMBHs have been acting like a long-lost relative that isn't interested in being found. Research, from 2018, suggested that these IMBHs may exist in the heart of dwarf galaxies, or very small galaxies. Observations of 10 such galaxies, 5 of which were previously unknown to science before this latest survey, revealed X-ray activity, common in black holes, suggesting the presence of black holes of from 36,000 to 316,000 solar masses. The information came from the Sloan Digital Sky Survey, which examines about 1 million galaxies and can detect the kind of light often observed coming from black holes that are picking up nearby debris. In 2015, astronomers using the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves from merging stellar black holes. David Shoemaker, the spokesperson for the LIGO Scientific Collaboration, LSC, said in a statement, LIGO's observations also provide insights into the direction of black hole spins. As too blacker to be a black hole is Cygnus X1. Cygnus X1 was the subject of a 1974 friendly wager between Stephen Hawking and fellow physicist Kip Thorne, with Hawking betting that the source was not a black hole. In 1990, Hawking conceded defeat. Number 4. Miniature black holes may have formed immediately after the Big Bang. Rapidly expanding space may have squeezed some regions into tiny, dense black holes less massive than the Sun. Number 5. If a star passes too close to a black hole, the star can be torn apart. Number 6. Astronomers estimate that the Milky Way has anywhere from 10 million to 1 billion stellar black holes, with masses roughly 3 times that of the Sun. Hi friends. I hope you are all learned basic of black holes. If you learned something through this video, then please support us. Have a nice day. Goodbye and take care.